In this video, I will walk you through free response question number 3 from the 2011 AP Calculus exam. This problem is mostly about finding the area of a region bounded by two or more functions and how to find the volume of a solid that is sitting on such a region. The functions f and g are given by f of x equals the square root of x and g of x equals 6 minus x. Let R be the region bounded by the x-axis and the graphs of f and g as shown in the figure above. For part A, we need to find the area of region R. You can find the area between a function and the x-axis by integrating that function. However, we have two different functions here, so we will need two different integrals. Function f goes from 0 to 4, so those are the limits of integration. So we will integrate the square root of x from 0 to 4. And then the second function, function g, goes from 4 to 6. So we will integrate 6 minus x from 4 to 6. As we integrate the square root of x, let's think of it as x to the 1/2 power. So I'm going to bring down the x, and I will add 1 to the exponent. That's going to make this 3 over 2. Then I divide by the new exponent. Dividing by 3 over 2 is the same thing as multiplying by 2/3. And we're integrating from 0 to 4. Moving on to the next integral, let's integrate this term by term. So integrating the 6, the antiderivative is 6x. And then for the next term, I bring down that x, I increase the power by 1, and then I divide by the new power, so I have a 1/2. So minus 1/2 x squared. And again, we need to apply the limits of integration. So back to the first term. This tells us that we need to find the value at 4 minus the value at 0. So we will have 2/3 times 4 to the 3/2 power. All right, that's the value at 4, minus the value at 0. 0 to the 3/2 power. Okay, so I'll come back to this. Now moving on to the purple, again, we need to find the value at 6 minus the value at 4. So here is the value at 6 minus the value at 4. Please understand that for the AP exam, on a free response question, you can leave your answer just like this. But let's keep going and simplify just for fun. Also, what if there was a multiple choice question? The answer is not going to look like this. So always practice simplifying just in case you run into a multiple choice question. When you have a fractional exponent, it is in the form power over root. So this is the third power and the square root. Let's start by taking the square root of 4, which is 2, and then we cube it, which is 8. So we end up with 2/3 times 8. Raising this 0 to the 3/2 power is still 0, so this term is just going to be gone. Applying the rest of the exponents and distributing this negative sign gives us this. Performing the multiplication gives us this. Adding all of these purple numbers gives us this. Writing with like denominators, we have this. So the area is 22 over 3. Part B, the region R is the base of a solid. For each y, where y is between 0 and 2, the cross-section of the solid taken perpendicular to the y-axis is a rectangle whose base lies in R and whose height is 2y. Write, but do not evaluate, an integral expression that gives the volume of the solid. When we talk about a solid whose base is region R. I want you to picture an oddly shaped loaf of bread that is sitting right on region R. In other words, the footprint of this loaf of bread is region R, and we are looking down from above. When they talk about cross-sections taken perpendicular to the y-axis, they are talking about horizontal slices of the solid like this one. Ultimately, we will find the volume of the whole solid by adding up all of these slices. Because the slices are stacked up vertically, we are going to have to add them by integrating with respect to y. In the setup of the problem, the red function and the purple function were both given to us in terms of x. However, because we are going to integrate with respect to y, we need to rewrite both of these functions in terms of y. In other words, let's solve these for x. Starting with the red function, if I square both sides of the function, I get y squared is equal to x. In other words, x is equal to y squared. So this is the version of the red function that we will use for this problem. For the purple function, if we add x to both sides and subtract y from both sides, we get x is equal to 6 minus y. So this is the version of the purple function we will use for this problem. Finding the volume of a solid sitting on a particular region is a three-step process. First, we need to find an expression for the base of a single slice. Next, we need to find an expression for the area of a single slice. And finally, we find the volume by integrating the area. When we integrate the area, we are basically adding up all of the slices, and that forms the volume. Step 1 is to find an expression for the length of the base of a single slice. In this picture, this blue segment represents the length of a single slice. We can find an expression for that length by subtracting the function on the right minus the function on the left. So an expression for the base would be 6 minus y minus y squared. Step 2 is to find an expression for the area of a single slice. But in this case, we are told that each slice is a rectangle whose height is 2y. We are looking down at this solid from above, but if you took out a slice and looked at it, it would be in the shape of a rectangle. The rectangle has base b and a height of 2y. For step 2, we need to find an expression for the area of this rectangle, but we know that the area of a rectangle is base times height. In other words, b times 2y. So, back to our main expression. We need to change this into an expression for area. Right now, this is an expression for the base. Well, the area is the base times 2y. So if I take the expression for the base and I multiply it times 2y, now it's an expression for the area. And that's the end of step 2. The last step is to find an expression for the volume by integrating the area. So here is our expression for area. We can turn it into volume by simply integrating this. When you integrate an area, you are adding up all of the slices. In this case, the slices are stacked vertically, so we will be adding them from bottom to top. In other words, we will be integrating from 0 to 2. Those are the limits of integration. And that's the final answer for part B. We were asked to write but not evaluate an integral expression that gives the volume of the solid, and this is it. Part C. There is a point P on the graph of f at which the line tangent to the graph of f is perpendicular to the graph of G. Find the coordinates of point P. So we are talking about two lines that are perpendicular to each other. The graph of G and the line tangent to F at point P. And point P is what we need to find. Here is a fact that you need to know in order to do this problem. The slopes of perpendicular lines are opposite and reciprocal. For example, if the slope of one line is 2/3, the slope of a perpendicular line will be -3/2. We can easily figure out the slope of g of x, and therefore we can get the slope of the tangent line. G of x is given by y equals 6 minus x. This is the same thing as y equals -x plus 6. Remember good old y equals mx plus b? The slope is in front of the x. The slope of g of x is -1. The slope of the tangent line, which is perpendicular, is going to be opposite and reciprocal. So it's going to be positive something, and the reciprocal of 1 is 1. So the slope of the tangent line is +1. Let's see if we can use this information to find the coordinates of point P. Remember that we were told in the setup that f of x is the square root of x. We know that the slope of a tangent line is given by the derivative. So let's find f prime of x. Well, okay, f of x, let's think of it as x to the 1/2 power. So for f prime, we are going to put the 1/2 in the front and reduce the exponent by 1. So that means 1/2 x to the -1/2 power. Rewriting this a little bit, we have 1/2, there's your 1/2. I'm dropping the x to the -1/2 power down to the denominator as the square root of x. So this is f prime. This derivative gives us the slope of the tangent line at any point. We want to find the point where the slope is equal to 1. So let's set this derivative equal to 1 and solve. So to find out where f prime is equal to 1, we need to solve this equation. The easiest way to solve this is to swap the denominator with this number out here that's by itself. That is a legal move. That gives us 1/1 is equal to 2 radical x. That means 1 equals 2 radical x, or we could write 2 radical x equals 1. Dividing both sides by 2, we get radical x is equal to 1/2. Squaring both sides of the equation, we get x is equal to 1/4. So that is the x-coordinate of the point of tangency. We just need to find the y-coordinate that goes with it. Well, y will equal f at 1/4. And remember that function f is the square root of x. So this will just be the square root of 1/4. So y will equal 1/2. So the point of tangency is 1/4, 1/2.